Hi, hello. Today, we're taking a journey back in time to explore the birth of our solar system. Bye, Earth! Many hypotheses were recommended by various philosophers and scientists regarding the origin of the Earth. And one of the earlier and popular arguments was made by German philosopher Immanuel Kant. And later on, a mathematician named Laplace revised it in 1796. And so, to understand this theory, I recommend that you go with this order. First, everything right from the sun, planets, stars, asteroids has been created from nebula cloud. Second, stars were formed way before planets and asteroids came into existence. Planets are somewhere around 4.5 billion years old, and the most stars are between 1 billion to 10 billion years old. And the sun is the biggest star in the universe. Remember that. So, what happened was initially there was this nebula cloud which is made of helium, hydrogen, and other sort of dust particles, so this cloud started rotating very heavily. And due to that, the most of the hydrogen and the helium elements came to the center and they start colliding with each other. And due to the friction and collision of particles, fusion reaction took place, pure energy started generating, and this create the sun. Isa sa mga tanong kung bakit ang araw ay pangunahing binubuo ng hydrogen, helium, kahit na mas magaan ang atomic number ng mga ito. So, sa madaling salita, ang hydrogen at helium ang dominanteng elemento sa universe at ang araw ay isang resulta ng natural na proseso ng pagsasanib ng mga elementong ito. Now, it's time for the planets to arrive. We know that hydrogen and helium are the low-density elements and they move to the center forming the sun, so it is very logical. If lighter element went to the center of the heavier would go away from the center, right? And that what happened. The heavier elements like carbon, oxygen, nitrogen, iron, phosphorus, silicon, etc. move away from the center. And if you see Earth and all other planets are made out of denser element than stars and then this heavier element, starting forming small dump of clouds like smaller nebulas with a further rotation, friction, and collision of particles. It led to formation of a disc-shaped cloud, and the planets were formed through the process of accretion because now the heavy elements will come to the center and the layer by layer planets started forming. So this was the early theory of the origin of Earth, which is also known as nebula hypothesis.
Ever wondered how our solar system came into existence? The nebular hypothesis holds the key. Around 4.6 billion years ago, there was a vast cloud of gas and dust in space. Something triggered the cloud to collapse, possibly a nearby supernova or a passing star. As it collapsed, it began to spin faster and flatten into a spinning disk, with most material gathering at the center. In the center, a dense ball formed, our sun. Around the sun, smaller clumps formed called planetesimals. These planetesimals collided and merged over millions of years, forming the planets we know today. And that's how the nebular hypothesis explains the birth of our solar system.